Hello friends, welcome back to my YouTube channel. Today we will discuss about the shear force and bending moment. So before discussing about the shear force and bending moment, firstly we will discuss about the beam. What is beam? Beam is nothing but the structural member which carries some type of load. That is the structural member which carries some type of load. The load may be parallel to the neutral axis of the beam, it may be perpendicular to the neutral axis of the beam, or it may be inclined. So if let load P is applied parallel to the neutral axis. If the load is applied parallel to the neutral axis, then it is called axially loaded beams. And if the load is perpendicular to the neutral axis, it is called lateral loaded beams. And the third one case is if load is inclined at some angle, let it be theta, and the direction of load is downward. So this load may resolve into two components, that is vertical component and the horizontal component through the beams. That is, horizontal component is parallel to the neutral axis and vertical load is perpendicular to the neutral axis. So the vertical load, that is the load which is in the downward direction, gives us the shear force and the bending moment of the beam. Similarly, if we are taking the horizontal resolved component, that is horizontal load, that is both these are the components that is resultant. So the horizontal load, that is horizontal component, gives the thrust. So today we will discuss here about the shear force and the bending moment. So let's choose a section here. Let's take another beam. Let's choose a section here and some load X is applied in the vertical downward direction. So due to this load, there are some stress induced in this beam. So we discussed here that the load, let it be P, is applied here in the downward direction at some angle theta with the parallel to the neutral axis. So this may be result in vertical and horizontal component. The vertical component gives the shear force and bending moment, and the horizontal component gives the thrust. So it is the resultant forces. Both are the resultant forces due to which these shear force and bending moment are nothing and but it is also called as the stress resultant. Due to this, it is also called the stress resultant. So let's take here an example. Let's take a cantilever beam here. Cantilever beam. What is cantilever beam? It is nothing but a beam having one end fixed. Let us suppose the length of the beam be L and the beam is in static equilibrium. Static equilibrium means that the forces are in equilibrium. So let's some load P is applied here. This load is balanced by some downward, that is this is vertical load P is applied here, which is balanced by some load V here, that is P and V. Here due to some this length, that is L, we have taken, and load is P, due to which the bending moment may generate, and this moment is clockwise. So this moment is balanced is in anti-clockwise direction due to static equilibrium. So in fixed support, that is cantilever beam, the horizontal load, the vertical, and the movements should be resisted. So another text and another beam which is also a cantilever beam. Let's take some load P is applied here at certain distance, let it be x. So we discussed here that the load P is balanced by some downward load. So for this we are taking here some section. Let's read this section or redraw here. Here is some load P. So due to this load P, which is balanced by downward load V, and here is some taken distance, that is x, we have already taken. Look at here. So the summation should be 0. So P, let's the vertical load which is in upward direction be positive, and here the downward direction load should be then negative. So P is positive taken here, so it's downward minus V equal to summation should be 0. So P is equal to V, that is the shear force. Similarly, the summation of moment here should be 0. So it is anti-clockwise here. So sorry, it is clockwise here and this is anti-clockwise here. So the moment generated here is P into x, and the moment here which is resisting moment, that is M. So clockwise is taken as positive and anti-clockwise is taken as negative. So Px minus M is equal to 0. So due to this the moment is equal to Px. That is called the bending moment. The criteria for taking the moment is positive here is not due to the clockwise direction. It is due to just that the upper portion is going to compressive nature and the downward section is coming in tension. So when this situation arises, the movement direction should be taken as positive. When it should be done when the upper portion is in compressive nature and the downward portion is in tensile nature. So thanks for watching this video. Please like and share this video also. Thank you so much.